Hello and welcome to today's lesson, Solubility Curves. So what is a solubility curve? There are charts and tables available that we can use to get an idea of how soluble a certain solute is in a certain solvent. We will take a look at two of them in the next two sections. Solubility curves, like the one shown here, tell us what mass of solute will dissolve in 100 grams or 100 milliliters of water over a range of temperatures. You'll notice that for most substances, solubility increases as temperature increases. Here's an example of reading the chart. Find the curve for KClO3. So I've outlined that curve in red for you. So at 30 degrees, at 30 degrees, approximately 10 grams of KClO3 will dissolve in 100 grams of water. So we go to 30 along the temperature side, and then where it hits the graph is approximately 10 degrees. Okay. If the temperature is increased to 80 degrees Celsius, approximately 40 grams of substance will dissolve. So we go to 80, and then over, we get approximately 40. Saturated solutions. On a solubility curve, the lines indicate the concentration of a saturated solution, the maximum amount of solute that will dissolve at a specific temperature. The molar concentration of the substance can be calculated as shown in this example. So we're going to determine the molarity of saturated sodium chloride at 25 degrees Celsius. Then, so from the curve, we're going to be able to see that the 38 grams of sodium chloride will dissolve in 100 milliliters of water at 25 degrees Celsius. So I can pull this up and show you. So here's the curve for sodium chloride. Right there. And then at 25, which is about here, and over, we get 38. So the first thing we need to do is we need to convert this to molarity. So we have 38 grams in 100 mils. That's a concentration, but it's not molarity. Remember, molarity, we need to first convert from milliliters to liters so that we can then figure out our molarity. So to do that, we have to times the bottom by 10, right? Because there's 1,000 milliliters in a liter. So if we times 100 by 10, we get 1,000. To keep our equations balanced, we have to multiply the top by 1,000. So that's going to give us 380 grams in 1,000 milliliters. Okay. Since we need to convert from grams to moles, we need to use the molar mass of sodium chloride, which is 58.5 grams per mole. So we have 380 grams per liter. We're going to multiply that by 1 mole for every 58.5 grams. The grams cancel out. We then end up with 6.5 moles per liter, or 6.5 molar. Above and below the curve. Values on the graph above a curve below a curve represent unsaturated solutions. More solute could be dissolved at that temperature. Values above the curve represent supersaturated solution, a solution which holds more solute than can normally dissolve in that volume of solvent. Some examples. What terms, saturated, unsaturated, or supersaturated, describe? A solution contains 70 grams of NaNO3 per 100 mL of H2O at 30 degrees. A solution that contains 60 grams of dissolved KCl per 100 milliliters of H2O at 80 degrees. Solutions. The NaNO3 solution is unsaturated at 30 degrees. A saturated solution would be able to dissolve about approximately 95 grams of NaNO3. Since there are only 70 grams in the solution, 25 more grams of NaNO3 could be added and would all dissolve. The KCl solution is supersaturated. At 80 degrees, saturated KCl solutions contain 50 grams of KCl per 100 milliliters of H2O. This solution is holding 10 grams of excess KCl. If a small crystal of KCl was added to the supersaturated solution, the excess KCl will immediately come out of solution. So we can look at this table again. Okay, so we were looking at the NaNO3, which is this line right here. Okay, at 30 degrees, we were told there was 70 milliliters. Okay, so that's below the line. And then the KCl is right there at 80 degrees. We were at 60. So we were up here above the line. So that's today's lesson, and we will see you in class tomorrow so we can look at some solubility curves.